Hi there. My name is Tina Tereshko, and I'm a product manager on Google BigQuery. And I want to thank everyone for joining on this session. There's just so much content, so many amazing stories to choose from. And so for myself, from all the other speakers that I'm joined with, I want to thank you for picking this session specifically. So this session is all about scale. Lots of data, large volumes of data, complex problems. But it's also about organizations that have a rich history of creative technology and a history of solving large-scale problems. And so what better way to demonstrate the complexity and scale of something than to have not one, not two, not three, not four, but 5 presenters for a session. I think this is a record for Next. So all of these organizations have solved technical problems for their relatively unique scale. And if you fast forward to 2006, Google had our own technical problems to solve. We couldn't do interactive analytics at Google scale. And that's where Dremel came along. So Dremel, for the past 10 plus years, has been powering Google's data and analytics infrastructure. And BigQuery, as most people in this room already know, BigQuery is powered by Dremel. BigQuery is Dremel. It's the same engineering team. It's the same infrastructure, the same code base. And so when you think about it, when you're running BigQuery, you're running on top of Google's innovation. You're running on top of Dremel. And what gives BigQuery its scale characteristics is its native cloud architecture, cloud-native architecture. It's unique architectural principles, unique architectural considerations. So it starts with a stateless multi-tenant compute cluster, which is really what Dremel is, right? Which is a really unique offering. And it's joined together by a logical storage system that scales into petabytes and more. And the two are wired together by our network that scales to petabytes. And then we started to go beyond that, right? We separate compute and state, intermediate state during processing, which accelerates many of our queries, gives us performance, durability, scalability characteristics. And then we allow to share data in place without creating data silos, without moving data around needlessly, right? You bring analytics to data, you bring users to data, not the other way around. And finally, we wrapped it all around in a fully managed offering that minimizes complexity and manageability overhead for your organizations. It makes it easy for you guys to use this type of technology at scale. And so there's this really, really good quote by somebody I really respect. BigQuery was built for scale. It's true. I believe this person. And so you don't have to believe me when you listen to this. Here's a couple of anecdotes that I found on Twitter from folks who really, really appreciate using BigQuery. Our queries have gone from 4 hours to 13 seconds. It's awesome. Here's another one. I can vouch for BigQuery. It's pretty magical. So now, I want to discourage folks from jumping on Twitter right this second and professing your love for BigQuery, especially using foul language. Please don't do that, okay? But the next one is really my favorite, perhaps my favorite Twitter quote of all time. It's from a gentleman who works at Spotify. And 2 years ago, when we started to work with Spotify, this is what he tweeted. Finally, I can tell the world that BigQuery is the best thing that has ever happened to me. I feel like if it's in caps, I have to shout it. And it's true. I mean, he probably doesn't have a lot of interests, but he's a brilliant engineer. And Spotify is a brilliant organization. Of course, a delightful product. Everyone loves using Spotify, but also incredibly creative technologists. And I'd like to please welcome one of them here on stage with me, Nicole. Nicole is going to share the story of how Spotify has embraced Google Cloud Platform and BigQuery specifically for their use cases. Please.
Thanks, Tina. I appreciate the intro. Hey, everyone, thanks for having me here today. I'll start with a brief introduction. My name is Nicole and I work at Spotify as a technical product manager in the data infrastructure tribe, which is our name for department at Spotify. Specifically, I work with a team that works on building tools and to support BigQuery across Spotify. So we work closely with BigQuery every day. We, in DI and as a whole, build internal tools and infrastructure to support data at Spotify. So before I get into this talk, I want to just apologize briefly if I get a little bit technical. Feel free to find me after the talk, and I can explain things in a little bit more detail if you have any questions. So I thought I'd start with a very brief history of the short history of Spotify in the cloud, which actually, now that I think about it, would be a great name for a band. I'm gonna have to do that someday. All right, so 4 years ago, when we started the transition to the cloud, at that point, Spotify was almost completely on-premise and bare metal. We were doing, I think at our largest point, we had something like 2,500 nodes in our Hadoop cluster and over 10,000 machines in 4 data centers around the world. And what we were finding is that even at that kind of scale, one of the largest Hadoop clusters in Europe, it still really wasn't enough. We were expanding rapidly in the US, and we were really having trouble keeping up with the growth and being able to do our analytical work. And that in particular was a really big pain point for us. Running a single query on this cluster in Hive could take us hours. So after a couple years of small experiments, we finally decided to take the plunge and move to the cloud. And before I move on, I wanted to give a brief plug to my amazing colleagues Josh and Ramon, who'll be giving a talk about the migration tomorrow afternoon. So if you have any interest in hearing more about how we did that migration to the cloud, please listen into their talk. So for us, the move to BigQuery was actually a really big success. It was rapidly adopted by the Spotify analytics and data science community, and to this day, it still remains one of the most popular GCP tools we use at Spotify. For us in particular, what it really meant for us was that we were getting fast results. We were able to add capacity a lot easier, and we found that the integration with the other GCP tools was a real big help. As well, one of the biggest wins for us was really how it democratized access to data at Spotify. It was really that ease of use meant that more people could be asking more questions and getting responses faster, which meant that overall we were getting a massively shorter time to insight. Using SQL, particularly as a querying language, was really powerful for letting people across the company ask questions of our data in a way that they had never been able to do before. So I thought I'd give you a quick example of how using BigQuery impacted our ability to ask questions of our data. So this is a kind of question that somebody a data scientist might want to be asking. How much time did users in Spain spend listening to Spotify in October of 2016? Before, when we were working with Hive, it would take us something like 16 minutes or so to get an answer for this one question. Now, when we moved to BigQuery, the same question only takes us about 33 seconds. So as you can see, a huge sea change in our ability to get those answers quickly. Now, if you multiply that by hundreds of questions asked by hundreds of people at Spotify daily, the kind of impact this kind of speed is going to have is really clear. And in case you guys are wondering, the answer to that question is the total hours are equivalent to nearly 10,000 years. All right, so what does it really mean, or what do we mean when we say petabyte scale? What does that really look like? Internally in Spotify, we sometimes refer to this as how big is data? And our answer for that is really, really big. So right now, Spotify has about 170 million active users listening to our catalog of over 35 million songs in 65 different markets. So as you can probably imagine, we generate a lot of data, and being able to ask the right questions in the right way becomes really important to us. And so that's what we end up using BigQuery for. So we use BigQuery to do that kind of analysis at a scale that we've never been able to do before. Right now, we have about 25% of employees at BigQuery that are using BigQuery on a regular basis, either directly or through custom tooling on top of BigQuery. We process around 400 petabytes of data monthly and store over 100 petabytes of data specifically in Doesn't even talk about things we're storing in other parts of the GCP product suite. And that also includes loading in around 500 terabytes of new data daily into BigQuery. And what that means is that in total, we end up running around 6 million queries a month. So that's a really big scale. So for us, that move to BigQuery has actually solved a lot of the issues that we used to have in our old clusters. But as we've grown, we really had to develop new techniques to ensure that we're going to continue to be successful. For us, we actually see this as a big win. We've moved beyond those lower level problems of, can we even get the answers we need, to the higher level questions of how do we continue to ensure good performance if our data doubles in size again. So I thought I'd start with a few things here that we've discovered over the past year that have helped us scale effectively in BigQuery. We found that the things we're doing fall into 4 kind of categories. The first being administration, managing how BigQuery is being used across the company. Second one is around education, learning about how to tune our BigQuery performance to get the best results. Third is integration, that's leveraging the APIs and other GCP products to get the right tool for the right time. And then finally, we have working closely with Google to improve BigQuery, so working on a partnership with them. So I'm going to dig a little bit deeper into each of those. First of all, when we talk about the kinds of things we were doing in administration to be successful, one of the first things we did was move to a fixed capacity model. This has been really helpful to us because it ensures that we have dedicated slots and helps us be predictable with our costs. And that's been a big win for us. It does mean that we need to think a little bit ahead to enable to grow our capacity, but we've been finding that it's actually significantly still better than the problems we were having in our on-premise Hadoop clusters for growing capacity. We still have a significantly faster speed of growth there. The second thing we do is we've been creating sub-reservations, which are kind of smaller pools within our larger reservation that allows us to isolate jobs and business-critical projects. And that's actually been really helpful for us, particularly because we regularly rebalance which projects have access to which pools. And that means that we're getting the best performance for the right time. A good example of this is whenever we're going to do a large backfill on our data, something went wrong, or we need to add some data into a table that already exists. We will move that particular project into its own sub-reservation with an isolated set of resources that it can use. And that means it's preventing that from impacting the day-to-day work of everybody else, but also ensuring that that particular job has the resources it needs to complete on time. That's been really powerful for us. We also make sure that business-critical projects are in their own sub-reservation. That means no matter what happens, they're always going to have access to the resources they need to complete those business-critical tasks. The next thing we've been working on has to do with education, specifically learning how to tune our performance as being one of the main things. For us, what that really means is learning how do we need to manage our concurrency, how do we use batch versus interactive mode to help figure out when jobs should run. These kinds of things help us ensure that we're getting the best performance when we're running things on BigQuery. The second thing we've been learning a lot about is the impact of Dremel architecture, understanding that it's not a relational database and that using a columnar data store actually provides significant benefits for certain kind of queries, but can be very different and not work as well for other kinds of queries. And so ensuring that people who are running queries on BigQuery across the company really understand how to optimize for the kind of architecture they're running on. And finally, the thing we do within Spotify is we have a very passionate community of BigQuery users, and we leverage that a lot to help share best practices around the company. Next, we work on integration. Specifically, we use BigQuery API wrappers to allow us to build our own set of custom tools on top of BigQuery to meet our own needs. This really allows us to do deeper integration with our own tools and environment while still leveraging that power of BigQuery behind the scenes. I find that that's been really helpful for us to continue growing and fine-tuning something for our specific needs. We also leverage the integrations with other Google Cloud data products, and specifically the ability to move data between different products easily. That allows us to really optimize about using the right tool for the job. Finally, we focus on building a good partnership, specifically with the Google BigQuery team, as well with our strategic cloud engineers that work with us here at Spotify. We work with them really to help keep expanding the features and capabilities of BigQuery that you really need to be able to operate at this kind of scale. What that means for us on a day-to-day basis is that we're talking with them about feature requests. And, as we're pushing the limits of what BigQuery does right now, we work closely in telling them, hey, these are the new features we need. This is where we'd like to see this grow. A great example of this for us is not too long ago, we were working on becoming ready for GDPR, the General Data Protection Regulation that rolled out in Europe a few months ago. And we realized that the technique we were using for encryption and decryption just wasn't going to scale to the extent we needed for GDPR compliance. So we worked closely with the BigQuery team to work on new tools and features that allow us to do that at the scale we needed to, and at the speed we needed to do as well. That's been really helpful. And then finally, we've been working closely with the support team at Google to help us with troubleshooting. Specifically, whenever we run into any issues or users have challenges, we have performance issues, we're able to really reach out and get quick responses and solve our problems very smoothly. And that's it for me. I'm going to pass that over to Tino to talk about the next person. Who's next?
I'm next. Hold on. We're good. Thank you, Nicole. That was fantastic. So Spotify has, at one point in time before moving to Google Cloud Platform, Spotify had the largest Hadoop cluster in Europe, or right up there, and highly tuned. They spent a lot of time thinking about performance and operational complexity, now they're working with us to solve the problems, which gives them an opportunity to focus on delighting their customers rather than trying to tweak certain HDFS variables or things that they may not think are important for their business. Well, Spotify's been with us for 3 years now, but I'd like to welcome on stage our next customer here, our next speaker, Tuan from Oath. You probably use a property of Oath every single day in your life. Oath has been with us on stage last time, and they've kind of grown since then. So it's really interesting to see the progression of where they're going and where they're going to be at next. Tuan, please. Thanks.
Thank you, Tino. So like you said, my name is Tuan Pham, and I'm a technical director at Oath on the Media and Analytics Warehouse team, also known as MAW. And for those of you who are not familiar or as familiar with Oath, it was basically formed last year after Verizon's acquisition of Yahoo, which merged it together with AOL. And that formed a kind of house of brands, represented here by what we like to show as orbs. Not an exhaustive list, but we have a lot of well-known properties, products, including Huffington Post, Flurry, Tumblr, TechCrunch, and Engadget, to name a few. So when we talk about media analytics, Oath, what we're really talking about is scale in terms of volume and velocity of data. We've spent the last year working with all the brands from the merger, trying to, from around the world and across their platforms, conforming their data and to bring it together presents a uniform business view of our company. We also try to serve a wide range of users and use cases. We provide KPI reporting for executives, product metrics for product managers and engineers, and then we also support editors by providing real-time, up-to-date information on the performance of their content. And so to satisfy all these use cases, we try to strive to provide a single, self-service, interactive, and scalable data platform. So to give a little history about how we got to this point and before we had BigQuery. Generally, at companies, when you start with analytics, you start small. You have a single pipeline presenting the data to analysts. And then you bring on more products, you have more requirements, and you start to add another stack, another warehouse. Companies grow, you acquire other businesses that bring in their own warehouses. These warehouses then start to interact with each other, and you have to kind of reconcile that information. And so you kind of land at a picture that looks kind of like this. You have a lot of specialized data stores that have evolved into data silos. You have a lot of engineering teams kind of repeating work, which is not very cost efficient. You load data into multiple places using different logic to process it, sometimes yielding different results. And then those differences eventually have to be reconciled somehow. You have divergent tech stacks that start to evolve. They use technologies like relational databases that when you reach a certain threshold, can't maintain with the pace of the services required. And so overall, you have a very poor foundation for building an analytics platform. So what was the solution? So Yahoo, obviously being a huge contributor to Hadoop, had the expertise to build out large-scale clusters for storing data, large ETL pipelines. We have clusters in tens of thousands of nodes. So that was not the issue. And what we really needed was a complementary service that could take that data, expose it, make it interactive, scale it with the needs of the business, and then also be kind of cost efficient. And so for us, that solution was BigQuery. We use that as the basis for our new architecture. It's able to scale with the needs as we brought on all the brands from our merger. It's flexible enough in terms of capabilities to satisfy the different use cases that we have for our users. It's a managed platform, so it brings lower operational overhead, and so it maintains relatively lower costs for us as well. So initially, when we started our pipeline, it was a very basic Hadoop design. We ingested our log data and event data into our cluster, processed that with Pig, staged it up in Hive, and then surfaced it to our end users through our BI analytics front-end tool, which was Looker. And this served its purpose when we started off. And if you remember the original chain, when you start small, everything works fine. And as Nicole said, they started with Hive as well. But as the demands grew, Hive couldn't keep up with the services that we needed to provide. So in looking at alternatives, we started to look at BigQuery. And actually, this diagram was presented at last year's conference by my colleague, Nikhil Mishra. As our first step for introducing BigQuery, we wanted to take a very measured approach for adopting it into our platform. This gave us the opportunity to work with the dev team, to understand the GCP environment, to understand how that worked with our cloud or our Hadoop environment, let us understand the capabilities and the shortcomings of the tools, and be able to figure out the right way to integrate it. We left it in there along with Hive, and still serving the data up through BigQuery, through Looker, so that our end users really didn't experience any difference in their service, except maybe some possible gains in performance and some functionality. And then it led to our current design, represented here. I think the biggest thing you can notice is all the data now is being served up through BigQuery. We've greatly increased the capacity that we store in there because we have brought in all this data and all the brands from our merger. We've added in a real-time pipeline in our system, which allows us to take advantage of BigQuery streaming ingestion capabilities. We've also started to take advantage of additional GCP services like PubSub, Dataflow, and Dataproc because of how well they work together inside of that ecosystem. And really, this overall presents a simpler design for the overall architecture that we're trying to achieve. And like I said, that architecture afforded us the ability to simplify the design. We've gotten rid of all those specialized data stores and data silos. We're able to unify things like the streaming and batch pipelines so that all our logic is centralized in a single location. We have the flexibility in terms of services to provide the data. We've added our own API on top of BigQuery API, so we could provide programmatic access to our users that require that. And as the needs require, we can scale up both storage and compute to meet the satisfy the needs as they grow. And here, the numbers kind of speak for themselves in terms of the amount of storage we have, the number of users, the amount of usage the users apply in terms of queries against our services. And really, the numbers kind of speak to the significance of our system, kind of the importance of it providing value for our company and the day-to-day decisions that our colleagues need to make. I think the numbers also speak to the validity of our choice in using BigQuery as the backbone of our infrastructure, because it has been able to grow to match the needs and demands of our services. So a couple learnings that we've had along the way, as mentioned before, GDPR as well. I'm sure a lot of us had to face that new regulation that took effect earlier this year, which was so enjoyable. But for us, it really presented a very daunting proposition of having to restate petabytes of data within our warehouse at a fairly frequent rate, which would have been very time-consuming, very resource-consuming, obviously very costly. And so we had to find alternatives to handle that. And in looking at those, we were able to settle using BigQuery DML. And what that allowed us to do was to apply massive scale updates and deletes on our data. It didn't require us to do any additional work in terms of reprocessing the data or having to restage our data. Everything was set. The functions were very performant to meet our expectations. We did work cooperatively with the dev team to get enhancements along the way, like being able to apply DML to streaming tables, which was one of our requirements. And we kind of continue to work with the dev team to try to improve the process by looking at things such as clustering, which we expect are going to yield additional performance gains. In terms of streaming, obviously being able to ingest event-level data into your warehouse is a huge advantage. And for us, we kind of applied a Lambda architecture where we overlay the real-time data with batch data. And so if you're querying for the last 10 minutes or the last 10 weeks of data, you're just going to the same table, using the same query, essentially. But it makes you think in different aspects. So you have to think in terms of quotas and the inputs and the amount of events and the size of those events. Of course, nothing comes for free. So what we experienced with tables with heavy streaming ingestion, there was going to be some performance impacts in terms of queries. So we had to work to kind of either overcome or be able to work with those situations. So in some cases, we used on-prem hardware to offset some of that. In other cases, we're looking at alternatives like micro-batching ingestion, which we're hoping will increase performance of those situations. I think the really biggest discovery for us is the independence of the quotas for a lot of the things that you can configure. Streaming ingestion quotas versus batch ingestion quotas don't impact each other. Querying as well as ingestion quotas don't impact each other. And what it really gives you is a lot of flexibility, a lot of on-demand flexibility to configure your situation, especially in highly dynamic environments, so you can handle any event that comes to you and be able to handle those accordingly. So in the media business, we encounter a lot of high-profile, high-volume events. There's late-breaking news. There's live sporting events. And so we went in an arrangement with the NFL to stream their content. And it was decided that we wanted to provide real-time metrics around the performance of that streaming. And for us, that meant experience peaks in terms of events and size of data that we don't typically have to encounter. So in looking at alternatives to satisfy those requirements, using the hardware route, we really didn't have the runway to procure, set up the hardware, not to mention what do you do with that hardware after the event is completed. And so we looked to BigQuery being able to dynamically increase our quotas, meet the expectations of the event, turn down the quotas at the end of that, and the best thing of all is you only pay for what you use during that time. We were able to handle that engagement with no issues in a very short amount of time, and so overall it was a very successful engagement. So what are we looking to do from here? Obviously, we want to continue to unlock the value of data that we expose in our platform. We're going to increase the volume, look at additional data sets that could provide value for other parts of the company. Looking at additional GCP services like machine language, being able to do things like user segmentation and clustering in that platform. And then we're working with the BigQuery team and Google on pre-releases and alpha and beta versions of additional features, which I won't mention here, not to take away the thunder from Tino and company, but they'll be announcing those, I think, shortly tomorrow. And with that, I'm done.
Thank you, Tuan.
I will take everything.
Okay.
Thank you so much, Swan. So the impact of the NFL game event shouldn't be understated. Tuan and Co came to us and said, hey, guys, we got this NFL game going on, and we're going to stream 4 gigabytes per second into your streaming system. And, we freaked out a little bit at first, but, they gave us enough lead time, and we delivered it. The important thing to note is that all the complexity was on our side, right? All Tuan's team was looking at is an API surface, right? So we went out there and we made sure that everything would work, right? Our SREs were on call. Everyone was very happy with the outcome. And they just sent rows to us. And then they paid for only what they consumed. So it's a great story. And the other call out I should say is, as you get to these scales, the anti-pattern space expands dramatically. Right? There are so many things that are unknowns that you encounter for the first time that you have to fix. So folks like Spotify and folks like Oath, the problems that they face and they work with us to resolve, straighten our system so that people who aren't necessarily at that scale get a more robust, more performance system. Well, now I'm going to kind of change the gears a little bit. Spotify and Oath have been with us for a while. They're operating at a huge scale. But we have a newcomer into our platform. I believe in April, Twitter announced that they chose Google Cloud Platform as their vendor of choice, or cloud vendor of choice to host their next generation data analytics platform. So that's early for them, but they're already getting some results. So I'd like to welcome a couple of engineers from Twitter who are going to be talking about how they're using BigQuery today. Please welcome Pawan and Roman.
Thank you, Tina.
Hey there, I'm Pawan.
And I'm Roman.
We're from the revenue platform team at Twitter.
And today we're going to talk about some of the compelling technical challenges we faced recently.
How BigQuery helped us solve them.
And where we go next. So at Twitter, we have a track record of BigQuery solving some of the problems that have been impossible to solve before. And we really want to tell a story of how we started to use BigQuery and what drove us to get here. 10 billion advertised events processed daily. So this is the scale we have to deal with. And what happens to this scale when something goes wrong? It's really hard to tell. So we had a need to write arbitrary queries against our data sets to answer some of these questions. And for a lot of our data sources we own, it's either impossible or extremely time-consuming. So with that in mind, I want Pawan to share one of the real-life cases, and I'll pass it to him.
So 2 quarters ago, we had a bug. Someone reported we showed ads to the wrong user, something we should never do. So first steps, identify if there are any other campaigns that were affected. Fortunately, we have tools to do that. It's called business audit records. Any change made to a campaign gets logged into this table in MySQL, and so all you have to do is to query it. Turns out it's really hard to do at our scale. We own one of Twitter's largest MySQL clusters, and this is one of its largest tables. You can literally hear MySQL scream in pain when you're trying to query a 3.2 billion row table. So how long did it take for us to finally answer the question, were there any other campaigns that were affected? It took us 2 weeks. It took us 2 weeks, 4 engineers, a DBA, and a whole lot of pain to finally answer the question. How could we do better? The data platform team has been experimenting with BigQuery for a while, and we thought it was the perfect technology to help solve our problem. with the power of BQ Blaster that Roman is going to talk about next, our data was ingested in no time. And now, things are as simple as writing SQL, but without the timeouts. This takes less than a minute to execute. And this was just one use case.
So we looked at this use case and a couple of other test cases, and we really saw a potential to answer questions in more depth if we move all our data sources to BigQuery. And here's where it becomes a really hard engineering problem. How do we generalize the ingestion regardless of the source and at scale? It was never an easy transition for us. BigQuery alone was not enough, and we really had to build a set of tools to enable those experiments, to see what queries we can run, and also what new questions we can get answered. BigQuery Blaster, or BQ Blaster, how we call it for short, is one of the first tools that we built for this, and let's see what it does. We started with introspection on our own systems, and with so many data sources and database types, we really wanted to build a tool that would abstract away the original data source. So the initiator for this would be a scouting job that picks up the data from any original source that we have and lands in a Google Cloud Storage. The very last step is a BigQuery import job that picks up data from Google Cloud Storage and lands it straight to a BigQuery table. So this is a tool in a nutshell. We also want to talk about where we go next.
So we took the learnings from this initiative and are applying it to our next challenge.
Getting the data organization right.
We consume more than 100 terabyte data of revenue logs per day.
Moving all of this into BigQuery is our next challenge, and we know how to tackle this now.
Thank you.
Thank you, guys. So you've heard some of the stories of folks who are doing interesting things at scale, who have lots of data, but I don't want to give you the impression that this is the only thing that BigQuery is good at. BigQuery has a wide range of customers of all scales and all sizes and all types of complexities. So much so that the vast majority of our customers are actually using our perpetual free tier. You get 10 gigabytes of storage and 1 terabyte of data processed every single month for free. Right? So if you have that much data, you never have to pay us a penny. And so we would encourage you to try it out if you haven't yet, because it might be a great tool for your use case, no matter how big or small. And of course, you can go take a look at cloud.google.com/free to get your $300 credits that you can use on BigQuery or any other product that you may like. And of course, you can take a look at some of the other sessions that we have. We have lots of customers talking about how they're using our infrastructure and our services. It's a varying style of use cases. So you can get a variety you can experience a variety of what people are talking about here.